Hello students, so here we are with the next video of some basic concepts of chemistry. So states of matter. How many states of matter are there? Matter exists in how many states? Solid, liquid and gas. So what is the difference between solid, liquid and gas? In solid states, it is rigid, it has got fixed shape, it has got fixed volume. While liquid, there is no rigidity, no fixed shape, but fixed volume. And gaseous state, there is no rigidity, neither fixed shape nor fixed volume. So, what do you mean by this? In solid, the particles are closely packed. So, because of the close packing, the molecules are closely packed and hence it is rigid and it has got a fixed shape and fixed volume. While in liquid, the molecules are moving. The particles are moving and that is why it doesn't have fixed shape nor it is rigid, but it has got fixed volume. In gaseous state, it is the molecules are in continuous motion. They have got high kinetic energy. So therefore, they are neither rigid nor fixed shape nor fixed volume. The intermolecular spaces, the space between the molecules in the solid is very less and intermolecular force of attraction is very high. So that is why the particles have got close packing. While in liquid, the intermolecular forces and intermolecular spaces are intermediate of solid and gaseous state. While in gases, the intermolecular forces are very small, almost negligible, and intermolecular spaces are very huge. So, the molecules are in continuous motion. That is why they don't have any fixed shape or fixed volume. If you compress solid, it cannot be compressed, it cannot be squashed. While liquids, if you compress them, they will not be also squashed. But in gaseous state, if you compress it, it gets compressed. So these are some of the properties of the different states of matter. Now these states of matters are interconvertible. Let's take for example water. Water in the solid state is known as ice. Liquid water is what we drink and gaseous water is the vapors. So this solid when you heat it converts to liquid and the liquids when you heat further it converts to the gaseous state. This gaseous state if you condense it changes to liquid state and liquid state further if you freeze it or it changes to the solid state. So on increasing temperature, solid changes to liquid, liquid changes to gas. On decreasing temperature, gas changes to liquid, liquid changes to solid. So these are some of the properties of the different states of matter. Now properties of matter and their measurement. So if you are given some substance and you have to identify a substance. So to identify a substance, you need the properties of that substance. What do you mean by the properties? They are characteristics. Every substance has got some characteristic properties. So the two types of characteristic properties are the physical properties and the chemical properties. Physical properties are those which can be measured or observed without changing the composition. For example, color of the substance. So if you take a piece of gold, the color is what? Yellow. Odor, it doesn't have any specific odor. Melting point is having a specific melting point, boiling point, density. So by these characteristics values, you can come to know whether what is the substance of. So these are known as the physical properties. So chemical properties are the chemical properties that undergo chemical changes. So like for example, if you oxidize a substance, for example magnesium, if I burn it, what happens? It gets changes to the ash. So this ash is what? Magnesium oxide. If you burn coal, what happens? It produces ash, it produces gases, carbon dioxide gas. So this is the property of coal. So by when there is some changes done, some reagents added or heated, some changes are done in the chemical composition, that those are its chemical properties. So let's say for example if you are taking sugar. Sugar if you dissolve it in water, it dissolves. So it is soluble in water. If you take salt, if you dissolve in it water, it dissolves. So it is soluble. It is also soluble in water. So solubility is the what? Physical property. While if you react if you react calcium carbonate, let's say if you are taking and adding HCl to it, what happens? It produces carbon dioxide gas. So by that chemical change, you are able to identify that the substance is what? Having carbonate group present. So basically by the physical and chemical properties, you can identify the type of matter, and those are known as characteristics property. Then many properties are measurable. They are quantitative in nature, while some other properties are qualitative in nature. So quantitative properties are which one? Mass, length, area, pressure, volume, time. These are all what? Quantitative in nature. Let's say you have to measure the length of this laptop. So how do you measure it? I can say the length is 10. What do you mean by 10? Hmm? What do you mean by 10? It is just a number. It cannot give any clear picture about what I'm speaking about. But if I say 10 meter, that gives a sense. If I say the length of some room is around 10 meters. So what does it say? It gives some demarcation to the value. So this meter that we have added is a unit of length. When you write this unit of length, then only it makes a sense. So measurement of the properties requires units. What are units? They are the arbitrarily decided and the universally accepted standards. Okay, so these are the units. Now if you take SI units, there are certain quantities, fixed quantities who has the SI units. They are fundamental units. So for mass, the unit is kg. For length, it is meter. For time, it is seconds. For intensity, it is candela. For current, it is ampere. For temperature, it is Kelvin. For amount of the substance, it is mole. And for intensity, I said, it is candela. So these are some of the fundamental units, SI units, standard units. So these units are expressed in different systems. CGS system, FPS system, MKS system. What is CGS system? Centimeter, gram, second system. What is FPS system? Foot, pound and second system. What is MKS system? Meter, kilogram and second system. So these are basically some of the systems in which the units are expressed. So base, physical quantity, symbol of the quantity, name of the SI unit and symbol of the SI unit. So let's take for example length. Length is represented by small l. And the SI unit for length is what? Meter. And the symbol is small m. Then mass. Mass, the symbol is what? Small m. And the name of the SI unit is what? Kilogram. And the symbol for the SI unit is what? Kg. Then time. Time, the symbol for the quantity is what? Small t. Name of the SI unit is what? Second. And symbol is small s. Then electric current. The current symbol is what? I. The name of the SI unit is what? Ampere. And how do you represent ampere? With capital A. Then temperature. Symbol for the temperature is what? Capital T. And the name of the SI unit is what? Kelvin. And what is the symbol? Capital K. Then amount of substance. Symbol for the quantity is what? Small n. The name of the SI unit is mole. M-O-L-E. And the symbol how you represent is M-O-L. Then luminous intensity, it is IV symbol and name is candela. Name of the SI unit is candela and the symbol of representing the unit is CT. So these are some of the standard fundamental units. Other units are derived from these units. For example, if I say the quantity volume, the volume, what will be the formula for the volume? Length into breadth into height. That means the unit for length, breadth and height is what? Meter. So the unit for volume will be what? Meter cube. When I say force, force is what? MA. That means mass into acceleration. So mass into acceleration, the unit is what? Unit is Newton or unit is Newton. Kg meter per second square. Okay. So the other units, other quantities will be derived from these physical quantities. So what is mass? How do you define mass? So mass is the matter a measure of a quantity of matter that body contains. So the matter that body contains, the amount of matter that body contains is called mass. And the SI unit of mass is what? Kilograms. And in CGS system, the mass is unit is what? Grams. Then length. Length, where all we have length in chemistry. So length usually expresses the properties like atomic radius, wavelength, bond length. These are all the basically the measurement of length. The SI unit of the length is what? Meters. And the CGS unit is what? Centimeters. Then temperature. What is temperature? It is a measure of hotness or the coldness of an object. So how hot a object or how cold a object is given by temperature. And there are three scales to measure the temperature: centigrade scale, Fahrenheit scale, and Kelvin scale. Then volume. I told you just now, volume is what? The amount of space occupied by the three-dimensional object is called volume. So if I say 1 liter, it means 1 dm cube, it means 1000 ml, it means 1000 centimeter cube. Let us say the volume of the cube. We have to find out the volume of this cube. The length of the cube is 10 centimeter. The breadth is also 10 centimeter and the height is also 10 centimeter. So if all the three are 10 centimeters, so the volume will be what? Length, breadth into height. That means 10 into 10 into 10. That is 1000 centimeter cube. And 1000 centimeter cube is equivalent to 1000 ml or 1 dm cube or 1 liters. Okay. So how can you measure the volume using this glass apparatus? See here, this is the measuring cylinder. This is graduated. So when you take water in it or any liquid in it, you can measure the volume of the liquid. It is 100 ml. There are markings here. Let's say I have to take 80 ml. So I'll take till here. Then 40 ml till here. So if it is colored liquid, you have to see the upper meniscus. Upper meniscus. And when you have to see the if it is a colorless substance, you have to see the lower meniscus. What do you mean by meniscus? Any surface is curved. So when it is colorless, you see the lower, and meniscus it is curved, that means it is like this. So when you have to see the colored substance, you have to see the upper meniscus. Meniscus will have the curvature on the upper side, and this curvature should touch the measurement, the graduation here, the indication here. Okay. Then this is pipette. This apparatus is called pipette. This is the volume of this is 25 ml. So if I have to take certain reagent, 25 ml of certain reagent for a reaction, so I can take it using pipette. So this is a marking here. Then this one is burette. So for burette, what you have to do? This is burette has got 50 ml marking. So with this burette, you can remove 50 ml. Okay. Then this is volumetric flask. This again has got a marking here. So if you have to remove this to prepare a standard solution, you can use this volumetric flask to prepare the standard solution. Okay. Then density. Density is what? Mass per unit volume. It is determined by the laboratory by measuring both the mass and volume and then dividing mass with the volume. Okay. Now see here, this bottle, the two liquids are given. One liquid is above and one liquid is below. So when you mix the two liquids and the layers are formed, so the upper liquid will have a low density and the lower one will have a higher density. Then similarly, if you add ice in water, ice floats. That means the density of ice is less than water. Okay. So here you see SI unit of density. How do you calculate density? Find out mass by observation, find out volume by observation, and divide mass by volume. So that's how you get density. And this density will be, the unit of this density will be what? Kg per meter cube. And the CGS unit is what? Grams per ml or grams per centimeter cube. Then temperature. Temperature is the degree of hotness of a body, we just now said. And the three scales are Fahrenheit scale, here you see Kelvin scale, Celsius scale and Fahrenheit scale. And these in these scales the temperatures are interrelated. So degree Fahrenheit is equal to 9 by 5 degree centigrade plus 32. So if it is 0 degree centigrade, that is how much Fahrenheit? It is 32 Fahrenheit. Huh? And similarly, there's one more scale, that is Kelvin scale. So Kelvin scale is equal to degree centigrade plus 273.15. So if I say 0 degree centigrade, in Kelvin it will mean 273.15. Okay, Kelvin. So this is how you can convert one scale of temperature to another scale. So here you see, I've asked a question here, 36 degree centigrade is how much Fahrenheit? So degree Fahrenheit is equal to 9 by 5 degree centigrade plus 32. This comes to 96.8 degree Fahrenheit. So the correct option is A. Then second one is, which of the following temperature will reach same value in Celsius and Fahrenheit scale? So degree centigrade is equal to degree Fahrenheit minus 32 into 5 by 9. So this is minus 40. So minus 40 is the temperature which is same in the two scales. Okay. Then temperature of 104 degree Fahrenheit is equal to how much centigrade? So we can calculate using the same formula. Degree centigrade is equal to degree Fahrenheit minus 32 into 5 by 9. So this comes out to be 40 degree centigrade. So the right answer is C. Okay. So these are some of the questions. You can solve more questions from your books and ask doubts. Okay. Thank you.